This is operations on functions. Let's have first addition and subtraction of functions. Let us have the addition of functions. The sum of two functions, f of x and g of x, is denoted by f plus g of x. This sum is defined as f plus g of x is equal to f of x plus g of x. This means that if we are asked to add functions, we simply add the functions, add the expressions. Let's have this example number 1. Given f of x is equal to 2x squared minus 4 and g of x is equal to x squared plus 4x minus 2, find f plus g of x. Again, f plus g of x is equal to f of x plus g of x. And this is simply equal to writing our expressions. We have f of x is equal to 2x squared minus 4 plus g of x. We have our g of x here, x squared plus 4x plus 4 plus 4 x squared plus 4x minus 2. And to add these two expressions, we are simply just like adding polynomials. No? If you could still remember your lesson in adding polynomials. When we add polynomials, we add similar or like terms. In other words, we will be looking for terms with the same variable and at the same time the same exponent. Okay? So in this case, we will look first for the variable with the highest exponent, and that is x squared. No? The term with the highest exponent of the variable x here is x squared, 2x squared, and 4 and x squared. Again, to add these two functions, we will look for the similar terms. Start with the term with the highest exponent of the variable. Again, start with the terms with the highest exponent of the variable. That is 2x squared. These two, we have 2x squared and x squared. So adding similar terms. 2x squared plus x squared is equal to, that is equal to 3x squared. Okay, that is equal to 3x squared. Next is, after x squared, then we have x. So we add the terms with the same variable and exponent of the variable. We have no other term here with x as the variable. Thus, we will just write 4x, no other term. And lastly, we will add the constant terms. We have negative 4 and negative 2. Negative 4 and negative 2 is equal to negative 6. Thus, the sum of g of f of x and g of x is 3x squared plus 4x minus 6. What did we do? Again, we substitute in our formula here, no? Again, substituting the expression for f of x, which is 2x squared minus 4, plus the expression for our function g of x is x squared plus 4x minus 2. And to add functions, we are just like adding polynomials. Okay? Now let's recall, how do we add polynomials? We add similar terms. So in this case, we start adding with the terms with the highest exponent of the variable. So the same variable at the same time, the same exponent. In this case, the highest exponent is x is 2, no? Then we have x squared and x squared. So we consider them as similar terms. 2x squared and x squared are similar terms. We add them because they are similar terms. We have 2x squared plus x squared then we have 3x squared. After x squared, we'll proceed to terms with x as the variable. X, no? The exponent is 1. Now, in our case here, there is only one term that has a variable x or exponent of 1, no? Of the variable x, and that is 4x. So we will just write it down, copy it, plus 4x. And lastly, we will proceed with adding the constant terms. We have negative 4 and negative 2. Negative 4 and negative 2 is negative 6. Thus, the sum of the functions f of x and g of x is 3x squared plus 4x minus 6. Let us have example number 2. Example number 2, the given f of x is negative 3x squared plus 13, and the g of x is x cubed plus 8x squared minus 10. Again, find f plus g of x. Again, this is denoted as the sum of f plus g of x is equal to simply the expression for f of x plus the expression for the function g of x. Let's do this. We have, this is equal to writing down the expression for f of x, and we have negative 3x squared plus 13. Okay, in some cases, we put the expression in the parentheses, but we can also, we cannot also do that, no? It's okay that we will not put them in the parentheses. It's because this is still addition. This is yet addition. Okay, then we have plus. Okay, we have uh, plus the next expression. We have g of x cubed plus 8x squared minus 10. We have, okay, we have now g of x, f of x is negative 3x squared plus 13 plus our g of x is x cubed plus 8x squared minus 10. Again, we will add similar terms, and we start with the terms with the highest exponent of our variable x. Okay, then let's do this. We have alt equals, the highest exponent is 3, and that is x cubed. The term, there is only one term with 3 as the exponent of x. So we will just copy x cubed here, no? We will just put it here as the leading term of our sum. Then we have x cubed. Next is x squared. Okay, we have two terms with the variable x with exponent 2 x squared, no? X squared, and that is negative 3x squared plus 8x squared. We do the addition. We will just add their coefficients, no? Numerical coefficients. We will just add the numerical coefficients. That is negative 3 plus 8 is equal to positive 5. That is plus 5x, okay, plus simply 5x squared. X squared. So when we add similar terms, we will just add the numerical coefficients. We will just add the numerical coefficients and copy the variable and its exponent. So we have negative 3 plus 8. We are adding unlike signed integers. We subtract. 8 minus 3 is 5. And which is bigger? 8. What is the sign of 8? It's positive. Thus, we have plus 5, then copy x squared. And next is, we will proceed with the terms that have x. But in this case, there are no terms that have variable x. Thus, we'll proceed with the constant term, and that is 13 and negative 10. We have 13 and negative 10, or 13 minus 10, we have positive 3. Okay? Let us check if we got it right. Again, the f of x is negative 3x squared plus 13, negative 3x squared plus 13 plus. Our g of x is x cubed plus 8x squared minus 10. X cubed plus 8x squared minus 10. To add this, we have to add first, no, the terms with the highest exponent of the variable x, but there is only one term here, no, and that is x cubed, and we just copy it, no, as the leading term of our sum, x cubed. Then next is the terms with x squared. As you can see, we have 2, negative 3x squared plus 8x squared. and that is equal to positive plus 5x squared. And we'll proceed with the constant terms. The remaining terms we have plus 13 and minus 13, and that is equal to plus 3. Thus, again, the sum, or if plus f plus g of x is equal to x cubed plus 5x squared plus 3. Next, and the last example for addition of functions. Given f of x is equal to negative 2x minus 14 and g of x is equal to x squared plus 5x, find f plus g of 6. Now, in the given, x now has a specified value, and that is 6. We can also write this as f plus g of 6 is equal to f of 6 plus g of 6. That means we will evaluate the function f of x when x is 6, and also add and also evaluate the function g of x at x equals 6. But if we do that, we will have to do two, no, evaluation of functions. So it is better that we first add the two functions before we evaluate, no, evaluate the sum at x equals 6. What do I mean? It means that we will first do that. F plus g of x, no, we will first add the two functions. That is f plus g of x is equal to, again, f of x plus g of x. Meaning, before we evaluate the function, we will just first add the two functions. And then, the sum will be evaluated at x equals 6. Okay? So, add the two functions. We have, adding the two functions, we have f of x is equal to negative 2x plus 14 plus g of x is x squared plus 5x. And the sum would be, okay, we write first x squared, no other terms, with 2 as the exponent of x. Then we will just copy x squared here, write it here, no, as the leading term of our sum, and then proceed with adding negative 2x and 5x. So we will just add again the numerical coefficients. Negative 2 plus 5 is positive 3, copy x, then no other constant term except minus 14. Thus, the sum is x squared plus 3x minus 14. Now, we will not stop here, no, because it says here that we need to find f plus g of 6. So, evaluate the sum at x equals 6. Okay? Now, let me just denote this first, no, for it to be complete. Okay. Ay, makopya. Copy. Okay. So the sum is, the f plus g of x is equal to x squared plus 3x minus 14. Now, this is not yet our final answer because we are asked to give f plus g of 6. And we will evaluate this sum when x is 6. Again, to evaluate, we simply substitute. So we have 6 squared, 6 squared now, plus 3 times the value of x, which is 6 again, minus 14. Okay? And we have 6 squared is 36, plus 3 times 6 is 18, minus 14. Thus, we have f. I will now denote this as, okay, it should be written as g of 6. No? So, let me, that is f plus g of 6 equals 36 plus 18 is 54. Am I right? 54 minus 14 is 40. Thus, f plus g of 6 is 40. So again, in this example, we are going to evaluate the sum at x equals 6. So there are two ways of doing this. We can do this by evaluating f of x first when x is 6, and then evaluating g of x when x is 6. And then the two results will be added to get the sum 40. Okay, or we can first add the two functions, and then the sum of the two functions will be evaluated at x equals 6 or at the given specified value. Either of the two ways, we will arrive at the same answer. Now, let us have subtraction of functions. The difference of two functions f of x and g of x is denoted by f minus g of x. This difference is defined as f minus g of x is equal to f of x minus g of x. So again, subtraction of functions, we will still apply the uh, the shortcut or the rule that we do in operations with integers. We keep the minuend and then we change the subtraction to addition, and then we change all the signs in the subtrahend. Again, change the operation from subtraction to addition and change the signs of all the terms in the subtrahend. To better understand this, let us have example 1. Example 1, given f of x is equal to negative x plus 4 and g of x is equal to x plus 3, find f minus g of x. Again, f minus g of x is equal to f of x minus g of x. Let's do this. We have equals, what is f of x again? That is negative x plus 4 minus. In this case, we will enclose our subtrahend or our g of x in the parentheses. Okay? We have x plus 3 as the g of x. So again, remember, we will keep the subtrahend as is, negative x plus 4, change subtraction to addition, and then change all the signs of your subtrahend, change all the signs of your subtrahend, the signs of the terms. That means positive x will become negative x, and plus 3 will become minus 3. Okay? So again, you change subtraction to addition, and then change all the signs of the subtrahend. That means positive x will become negative x, plus 3 will become minus 3. And then we proceed to addition. Okay? We simplify, we add. That is, out equals, we have negative x minus x, and that is equal to negative 2x. Okay? Negative x minus x is equal to negative 2x, and then we have the constant terms, 4 minus 3, that is equal to plus 1. Thus, the sum or the difference of f of x and g of x is equal to negative 2x plus 1. F minus g of x is equal to negative 2x plus 1. Let's have example number 2. Given f of x is equal to x plus 5 and g of x is equal to negative x squared minus 1 minus 2x, find f minus g of x. Okay, let's answer this. We have equals, writing down our f of x, which is simply x plus 5 minus, enclose in the parentheses the value of g of x. Let us just copy it here. Okay. Okay. Then, again, copying f of x minus, enclose in the parentheses the g of x. Okay, negative x squared minus 1 minus 2x, and simplify. Or, before we simplify, we will just do the keep, change, change. That is, keep the subtrahend, keep the minuend, change subtraction to addition, and change all the signs in the subtrahend. That means negative x squared will become positive x squared, and minus 1 will become plus 1, while minus 2x will become plus 2x. Okay, and simplifying, we have, again, we will start with the term with the highest exponent of the variable x. No other term except x squared. Then we will just copy x squared. Then proceed to the variable, to the terms with x. We have x plus 2x. That is, x plus 2x is 3x. And we have the constant terms, 5 and 1, positive 5 and positive 1. That is, wait, plus 3x. No? Again, x plus 2x is, sorry, I want to make it look nicer. 3x plus, okay, x plus 2x is 3x, and the constant times 5 and 1 is equal to 6. So again, the difference between f of x and g of x is this, x squared plus 3x plus 6. Let us have the last example for subtraction of functions. Given f of x equals negative x minus 9 and g of x equals 5x squared plus 1, find f minus g of negative 3. Again, the given value of x is, we have a specified value of our variable x, which is negative 3. Just like in the addition of functions, we can evaluate first the function f of x at x equals negative 3, and then evaluate also g of x at x equals negative 3, and then find the difference of the results. No? But again, we will be doing two evaluations of functions. But to make it simpler, we will first find the difference of the two functions. Okay? So we will find the difference first of the two functions. Let me just copy this and put it here. So instead of doing that, we'll first find the difference of the two functions. And that is equal to, what is f of x? Negative x minus 9. Then, what is uh, g of x? Again, is 5x squared plus 1. Copy, that is minus, enclosed in the parentheses, we have 5x squared plus 1. Okay? And equals, keep the minuend, minus, that is 5x squared plus 1. So again, change subtraction to addition, plus, no parenthesis. Okay, we have 5x squared will become negative 5x squared. Copy paste. Then plus 1 will become minus 1. Okay, wait. Okay, minus 1. So again, that is negative x minus 9 minus. It becomes addition. 5x squared will become negative 5x squared, and plus 1 will become minus 1. And then, let's simplify. We have, let's start with x squared, no? The term with the highest exponent of the variable x. No other term, then let's just copy negative 5x squared. Negative 5x squared, and then x, no other terms, no similar terms except x. So we'll just copy minus x. Okay, minus x, and then we have the constant terms minus 9 and minus 1, negative 9 and negative 1. That is now equal to negative 10. Okay, thus we have the difference between the two functions is negative 5x squared minus x minus 10. Now, we will evaluate this when x is equal to negative 3. And that is now writing C, or we will now uh, evaluate this, no, when x is equal to negative 3. And that is equal to f equals negative 5. Again, when x is negative 3, so negative 3 squared, sorry, minus, again, x is negative 3, negative 3 minus 10. So we substitute, no? We substitute in our expression, no? Negative 5 x is negative 3 squared minus negative 3 minus 10. And simplifying this, we have negative 5. What is negative 3 squared? That is negative 3 times negative 3. That is equal to positive 9. Then we have minus negative 3 minus 10. Okay. Then that is equal to negative 5 minus 9 is negative 45. And minus negative 3 minus 10. Okay. Let's have this one. That is equal to negative 5 minus negative 3. We keep change, negative 45. This will become plus positive 3. This is negative 45 plus 3 is negative 42. Minus 10 is negative 52. So again, negative 45 minus negative 3. This will become negative 45 plus 3. And that is equal to negative 42. Minus 10, negative 42 minus 10 is negative 52. Thus, we have f minus g of negative 3 is equal to negative 52. So f minus g of negative 3 is equal to negative 52. This is addition and subtraction of functions.